Hi.
So, hi, my name is Claire, and my final project was a self-balancing robot. So, for my first milestone, I tried to make sure that everything worked and get acquainted with how to use Arduino and motors and sensors. So there were the two main parts of my project that I figured out were the motor output here and then the IMU input for sensing the position of the robot. So for the first part of the two main components, so the motors, this is the motor driver, and it can control two motors at one time. These blue terminal connectors send output voltage to the motor here, and the pins on the right side come from the Arduino, and they get PWM input, which is pulse width modulation, so that's using high and low to mimic an analog output. So they use different duty cycles so duty cycle is like how long the pulse is on versus off. There are also A and B inputs, and those control the direction of the motor. The motor itself is a DC motor. It's brushed and it has a gear. And there's also the encoder on the back, which I was reading. The encoder uses a magnetic disc that spins while the shaft spins. And there's a Hall effect sensor, which basically it generates a voltage in response to a magnetic field that is created by the spinning of the disc. It has two channels, A and B, and so they're slightly offset, and you can see in this picture what it might look like if we were to look at the voltage coming out of the two channels. So there's the high and the low. Because the encoder disc itself it's magnetic, so this is what it would look like. And while it's turning, you would see this voltage output. And then you need the two channels because that's how you can tell the direction of which way the encoder is spinning. So the code is pretty simple. I'm just sending it A and B to change the direction, and then a PWM from analog to control the speed. So right now it's at 50%. And you can turn the pause button. And you can see it's spinning, and then if we turn the oscilloscope on, you can sort of see it's connected to the encoders, so you can sort of see that it's going up and down and up and down. Yep. So then for the second part of the milestone, I had to read the IMU, which is the inertial measurement unit, and that has two sensors, a 3-axis accelerometer and a 3-axis gyroscope. The accelerometer measures translation in the X, Y, and Z axes, and the gyroscope measures change in rotation in the pitch, roll, and yaw axes. So you need all 6 of them, all 6 degrees of freedom, in order to determine the position of the robot. But I only need one axis of each because the robot tilts this way, so I don't actually need all 6. I had originally wanted to port the library onto an Arduino Duo, but it wasn't working, so I stuck with an Uno. And we can run a sketch that was from the internet, and that maps the position of the IMU to a 3D cube on the screen. So we have to align the x-axis to the screen, press H to set it as a home, and now we can move it around and see its movement on the screen. I learned how accelerometer actually works. That was pretty cool. I also created a basic electrical schematic diagram of how everything comes together for the main components of my robot, so that was really useful when I started building. And my next step is to sort of connect these two so that the sensor input can be sent to the motor output, so it will react to the sensors.